Yeah, so we can quickly in 1 minute summarize all that we said shared yesterday. Let's take let's take two persons or three persons. Um, okay, so we're gonna take Boluatife, we're going to take Hope, we're gonna take Ebenezer, and we're gonna take Kende. So let us a quick if we can summarize what we learned yesterday or what was shared yesterday. So let's see who's gonna go first. So we'll just do like a 5 minutes, just spend 5 minutes to just summarize what we shared. So let's start with Folake. Folake, are you there?
Yes, can you hear me?
Yes, I can hear you.
Okay, so yesterday we spoke about STP, the spanning tree protocol. We said it works in the layer two, like in the layer two. And what we need to know is that it is okay. We spoke about the fact that it is used for looping, and we do that by placing redundant interface in a blocking state. We
Wait,
also
wait, wait.
spoke about
Did you say it is used for looping?
like the STP protocol to
It's
prevent.
exactly okay. So keep on cooking. I love the food you are cooking.
Okay, so we use a switch known as the BPDU
Hmm.
to know which packet. Omo, which packets
what's a what's a BPD?
breached protocol data unit.
Bridge what?
Breached protocol data unit.
Okay, so how does a switch use that?
Okay, they learn information about each other, about the network topology to
Okay.
know,
And
and
how,
they
af,
also
in after how many seconds do they
said in
send?
every 2 seconds.
Every what?
Every 2 seconds.
Okay, so how long does it take for a switch to learn its topology? Like when probably a redundant port is down, how long does it take before the switch learns and switches to a different port?
I'm not sure. I don't know. Was it 10 seconds or something? I can't remember, honestly.
Okay, okay. You've tried actually. Thank you. Um Ebenezer, yeah, 30 seconds. Ebenezer, so can you do a summary of what we did yesterday?
Okay, just to add to what Polaka has said, I mean, because if I see what she said, it would be like I'm repeating almost what she has said. But just to add, you said talked about network loops, and you give it like an explanation about network loops and stating that it is how did I even explain that yesterday? It is some sort of infinite loops that allows packets to somehow they collide with each other and then result into network failure. That's how best I understood that. Then you also stated that STP places redundancy points in the blocking state. Yeah, you also talked about inter-VLAN routing. And you also mentioned that switches the reason why some things can happen in switch and what can go wrong. For example, probably it is linked to a MAC address, or the VLAN is not properly connected to the switch, or the switch is not connected to the right VLAN. Then you also give us like 4 rules of networking. which you did not mention the fourth one. You said you were going to say it at the end of the class, but you did not eventually. So, yeah, there and there, yes.
Okay, thank you, Ebenezer. Who else did I call? I think I called Kendi, and who else? I think Daniel Abi or who. So maybe we'll have Daniel first. Or was it Boluwatife? Oh, okay, yes, it was Boluwatife. So Boluwatife, let's have you then. After Boluwatife, we have Kendi. Boluwatife, are you there? Your mic is not on in case you're talking. You're outside. Is it Oble or you're stuck in traffic? Okay, no problem. Okay, let us have Kendi.
Hi, good evening, guys.
Believe in Kendi.
Okay, so what I understood from yesterday's class, we talked about STP, which is Spanning Tree Protocol. So what me I understood is that Spanning Tree Protocol, it helps to prevent loops in the network. When there are multiple redundant paths between switches, STP prevents loops. So loops happen when there are multiple paths in the switches, which can bring the network down, right? So the S to prevent that. Then I think you also talked about BPDU. Yeah. And you said that BPDU is like a message that switches send to each other. And all. So yeah, that's it.
Wow, that was a very good summary. Hope, can you hear us now? Is Hope there? how can Hope see the messages but not hear the voices? I think the QoS of our network is not functioning properly. Hope, can you hear us now? Hope, can you hear us now? I don't think she can hear us. So let us quickly do a refresher quiz. Um, so let's see. So that's the way we did it yesterday night. Right, you type the answer in the chat box. Hope, can you hear us now? Hope, once you can hear us, you can let us know. So we'll just quickly probably start the quiz. Is everybody here? Yeah, Benza is here, but Daniel is here. So if we are ready for the quiz, just give me a thumbs up. Okay, so let's just quickly do the quiz. So what is the primary function of spanning tree protocol in a switched internet network? A, to load balance, B, to create a single loop-free logical topology by blocking redundant layer 2 paths. C, to encrypt data transmissions between switches and end users. D, to prevent layer 3 routing loop between different VLANs. This is simple. Okay, answer is B. Alright. How does STP determine which switch will become the root bridge for a layer 2 domain? The switch that boots up first and sends the initial bridge protocol data you need. B, the switch with the highest MAC address and highest priority value. C, the switch with the lowest numerical bridge ID, which is a combination of the STP priority and the MAC address. D, the switch with the fastest link speed connected to it. So what is going to be our answer? The answer should be C. Yeah, the answer is C. So if you chose C, you're right. The answer is C. So that's the number 3. A switch port connected to a desktop computer is mistakenly left with port fast feature enabled. When the computer is plugged in, it experiences a 30-second delay before getting a working network. What STP state is causing the majority of this delay? The switch port connected to a desktop computer is mistakenly left without, okay, what state is causing this delay? Disable state, which is waiting for an administrator to enable the port. B, the learning state, which is waiting for the DHCP server reply. C, the blocking state, which is waiting for a superior BPDU. D, the combination of the listening states and learning state as the switch verifies a loop-free topology. What's your answer? What's the answer for this? More responses. Okay, the answer should be D. So we're right. We're on a very good streak. The network engineer wants to ensure that the malicious device or another unauthorized device cannot accidentally disrupt the network's root bridge election. Which feature should be enabled on all user-facing access ports and server ports? A, BPDU filter. B, port security. C, loop guard. D, root guard. What is our answer? What's our answer? Everybody's choosing B. B. So what's our answer? Please, can someone help me type on the group that Hope should try and check if our laptop's mic is on mute. Answer is look guard actually. Ah, sorry. I just knew it wasn't port security. I've forgotten all these things actually. But I think yeah, this there's a loop guard, there's a root guard. Oh yeah, this is the answer. It's not port security anyway. Um, five. Not be everything person will remember. But yeah, I think it is the root guard. So the following link speed has the lowest best, making it the most desirable path for STP to choose. This is straightforward. This is simple. Just from the logic of yesterday's question to be able to get it. If we stick to the logic of yesterday. So what's our answer for this? Uh, we're not responding. Ah, what is going on? Okay, yeah, the answer is A, the one with the most bandwidth. Ah, nah, no. This is actually wrong. This answer is wrong. This answer is actually wrong. This answer is because I think the higher the bandwidth. Let me see. They didn't even explain. The 4 cost is 2, lower than 4, but 1 GB per data from the provided option based on common standards and cost ranges. Waiting cons waiting concern us with cost. No, no. This me I no go gree for this one. Oh, me I no go gree. Azal. Gemini want the one. Wetin do chat GPT right? Now, answer is 10 gigabits. Gemini won the wine. That's the lowest STP part cost. It's the most preferred part in STP's decision making. Gemini, take your time. Oh. I, I done the IPO. Yesterday, that's what I chose because there was no 10 gigabits in the option, right? So the trick is the higher the bandwidth of the interface, the more it is the most preferred choice, right? So the higher the bandwidth, the more it is the most preferred choice. So a 10 gigabits interface has a higher bandwidth than a 1 gigabit interface. So let's go to this. A switch port is configured as an alternate port that it is blocking. What is the primary reason this port remains a blocking state, even though the physical link is up? A, it has been treated as a security risk by the switch security policy. B, it has an inferior path cost, the root bridge, compared to the port that is currently the root port. C, it is waiting for the administrator to manually enable the link for load balancing. D, it is not receiving any BPDUs from the connected switch. Hey, this is tough. This one is tough, Sha. I'm not quite sure which answer I want. C can never be the answer. Right. D is wrong. The answer is between A and B. Answer is between A and B, and to me, both of them look very right. But if I was in an exam setting, I most likely would pick a B as my answer. I most likely would pick B as my answer. Yeah. We are right. So, which enhancement to the original STP standard allows for per VLAN load balancing and running a separate spanning tree instance for each VLAN? The answer is obvious. Based on how the question is even set, the answer is obvious. So, what are we picking? Daniel says D. Okay. Hope, can you hear us now? Alima, I'm not seeing you type. I'm not seeing iChat. I'm not seeing Ebenezer type again. You have left it for Daniel.
No, me, I don't know this question.
Some questions you just use sense. Just use sense to carry it. It's not everything you would know too. I think the answer is D. I think so. But I'll not be shocked if it's A or B. But I think the answer is D. Yeah. I think we are right. So 8. A switch received a BPDU on one of its ports. What essential information is contained within the BPDU? The entire routing table, B, the MAC address line on that switch and the DHCP leaves information. C, the VLAN trunking protocol. D, the root bridge ID, the sender's bridge ID, and the root path cost to reach the root. Ah, this is tough. This is tough. It's not tough. What am I saying? The answer is obvious, very obvious. I didn't even read it well.
Right.
Yeah?
Is it B?
What did you say?
I say, is it B? Can you?
B for boy.
D, dog.
Yeah, I think that's the answer. I think that's the answer. I think so. Yeah. Yep. A network is running rapid spanning tree protocol. When an active link fails, how long does it typically take for the alternate port to transition to a forwarding state and restore connectivity? Rapid A exactly 10 seconds. B answer is not B, answer is not C. Answer is between D and A. Answer is between D and A. Answer is between D and A. But as a network engineer, I am tempted to go with A because it doesn't make sense that it should be less than 1 second. But it's looking like anywhere there's star is what the answer is. I don't know why I've noticed that. It seems as though anywhere where there's star. I think the answer is actually 1 second. Yes, you are right. You are right. You are actually right. Yeah, you are right. I just remembered something actually. So it was when I remember that I actually remembered there was a rapid spanning tree protocol is an upgrade to normal spanning tree protocol, right? And the transitions were configured to be better than STP. So yeah, final question. Now, in an STP topology, the path cost to the root bridge is equal across two links on a single switch. What is the next tie breaking criterion the switch will use to select the root port? So we're going to answer this question at the end of the class because it ties into what we're going to do today. So yes, let's get into the task for today. Um, Apparently, my laptop is no longer charging, so I need to put in battery save mode. Um, Israel. So let us begin. So yeah, let's not forget that the first rule that I said about STP is that STP puts the first rule is that STP puts redundant ports in the blocking state, right? So that's the first rule, right? So and we also saw that how STP works is that a switch sends BPDU frames out of its ports every 2 seconds. Now the question is, why does the switch send the frame every 2 seconds? It's for two things. One, to learn its topology, right? To understand what is connected to it through the BPDUs. Now, the way BPDUs work is when a switch sends a BPDU, right, most of the devices will get that BPDU. Any device that is connected to the switch will get that BPDU frame. But only switches would respond, all right, or they would acknowledge, right? So if I go to the simulation again, if I go into the simulation mode, right, we'll see that when the switch sends the BPDU frame, all the devices connected to it receive the frame, right? But all the other devices rejected it, apart from the access point and the distribution switches. You can see there's a check. So switches send these BPDUs to learn of their topology, and that frame is important to switches. Other devices don't care much about that frame, but switches use that frame to learn of their topology. So when you are setting up this network for the first time, now I chose my words carefully. When you are setting up the network for the first time, all the switches will be sending the BPD, all the switches. Now, if you notice this network, what do you notice in this network? You will notice that there's only one switch constantly sending the BPDUs. The rest are just distributing that same BPDU frame from the Odogu switch. So if I fast forward, so that this is the switch sending the frame. The rest are just redistributing what this one sent. The rest are just redistributing. They're redistributing. So the main frame comes from this one itself. So, but when you initially set up this network, all the switches will be sending the frame, right? So it gets to a point where it is only one switch that will be sending that BPDU frame. Does it make sense? Is anybody confused so far? Okay. If you are confused, you can raise up your hand. Someone has to be confused now. I'm not so much of a great teacher like that. That someone would be confused. Gabriel that just joined is already raising up his hands. Okay. So let me take it again. Let me take it again. All right. So I said that when you initially set up this topology, right? When you initially set it up and you have these switches connected to each other for the first time, all of them will be sending that BPDU frame. So this pink stuff you see from this switch, right? Let me fast forward. This pink frame that you see, all the devices will be sending it to simultaneously when you first set it up. And why are they all sending? They are all sending it because every switch, when they are first connected to a network, they believe that they are the root bridge. Now, I said something about root bridge yesterday. Now, root bridge in STP is the Odogu switch, not based on capability. There are some requirements that that switches look at in choosing the root bridge, right? So if I quickly go to Google, right, and search what is the root bridge switch, is the designated central switch in a network using the spanning tree protocol that serves as the primary reference point for the entire network topology. Now, this is the criteria it is chosen based on. It is elected based on the lowest bridge ID, which combines the switch priority and MAC address, right? So I will explain that soon. So in the frames, because they believe that they are the root bridge. So let's see something that's going to happen. Let's see if I had another switch to this topology. Let's see what's going to happen. One more stupid love song, ambition. One more time. So let's see what's going to happen. If I connect it to this, this receives. Okay, so I can't use that example because for me to use that example, I have to create the topology again from the scratch. But let's see what we can do. Because I believe this will help us understand. So I like it when we understand stuff than when I'm just talking in theory. I like it when you sit with your own two koro eyes so that you not say I'm bubbling you. Right, so we have three switches like this. We're going to just run simulation, right? Connect here, connect here. The problem is so what we're gonna do is bear with me is just for us to also understand it more, right? So bear with me for a moment. So I'm just quickly going to open a new Cisco packet tracer file. One more. I still need to read this night, and my laptop is disappearing. 1, 2. Let's enter simulation mode. I'm going to connect the switches to each other.
Well,
Yeah, I'm with you.
why were you not able to like do this same topology on the not the topology, sorry, the simulation you wanted to do? Why were you not able to do it on that packet tracer file? That other one.
Because I have another network.
Okay. So it will
So
affect the simulation.
yeah, it would mix up with the simulation. This switch is already sending BP deals.
Okay.
I need to delete all of them. So we want to see what would happen when we're just getting them for the first time, right? So simulation, real time, simulation mode. Nothing is happening in this network for now. So let me connect this to this, this to this, and this to this. This is a network loop happening here. So let's play. You can see red. This is sending to this. So this is sending to this, right? So this one will soon send. This is sending again. This is rejecting. It's gonna take a while though, but let's just see. This is sending to this now. Now this is sending to this. This is going to take a while, but okay. So I think that's about it. Yeah. So this one just sent. This switch just sent. You see, just sent to this. So the point is this rejected. The point is all the switches will first send their own BPDU frames out of all their interfaces. So when you first connect for the first time, all the switches will send out BPDU frames. Why? Because they assume that there's an assumption from the switches that they are the root bridge. So it is when they've sent all those frames out to other switches in the network that they will start receiving BPDU frames from other switches in the network. And it is when they receive those BPDU frames from other switches that they will now understand which switch is the root bridge. So the question is, how do they understand which switch is the root bridge? When a switch gets a BPDU from another switch, how does the switch decide that, oh, be like say this switch is superior to me, so let me stop sending a BPDU frame and let me just accept, let me agree that this switch is better than me in terms of STP. Now we're not looking at the betterness in quotes based on the performance of the switch, whether it's a layer 3 switch or it's a layer 2 switch. No, we are looking at it from a criteria, some criteria, right? And the criteria is in an STP domain, the switch that is giving the root bridge is the switch that has the lowest bridge identity, right? Is the switch that has the lowest bridge identity. So if you break down a BPDU, right? If we break down a BPDU, you will see that a BPDU contains the bridge ID. When a switch sends a bridge protocol data unit, there's what in the BPDU you will have protocol identifier, you will have protocol version, you will have BPDU type, you will have root identifier, which is the bridge ID, the bridge identifier, sorry. So this root identifier, so that there's really no difference per se between this root identifier and this bridge identifier, except that this this will not be there in the first time. This will not be there, right? This bridge identifier would be there, and in this bridge identifier, when you break down the frame, this bridge identifier is the most important part in choosing the root bridge. So it would have priority, bridge priority, and MAC address. Now, Usually for all switches, the default bridge priority is 32768, right? So why is it 32768? It is 32768 because the if you break down the bridge ID is equals to bridge priority plus MAC address. MAC address has 48 bits. Priority has 16 bits, right? So if you turn those 16 bits into one, so if I say convert 1, 1, 1, 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 to decimal, it should give us 32768. So GPT, oh, Momat ni, hey, oh, girl.
Well, sorry. Please, where is this 11111 from?
Don't worry, let it give me my answer first.
Okay.
So the answer should be 327. Abi, what's he giving me 65535? No, now. Oh, okay. I know what the problem is. Let's see. Let me try to say 00. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's see. Pam, 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 pam. Pam, 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 pam. What's ChatGPT doing for me now? I'm coming. Food is ready. Amazing. Did you keep for Ibrahim?
Yes, the rice is small.
Uh, so we should cook more rice, I think. So are you going to cook the rice? Thank you. Yeah, so 32768. Yeah. So Alema asked a question. Sorry, they brought my food. Sorry. Ali- yeah, Alima asked a question. So I said that the roots, the BPDU, right? When now, um, hmm, so if you break down an Ethernet frame consists of many parts, right? In that Ethernet frame, you would have source IP address, you would have destination IP address, and destination IP address is 32 bits, source IP address is 32 bits. You would have flags, you would have identifier, you will have a lot of different segments of that frame, right? So a BPDU frame has different segments, and one of the segments is called the bridge ID. This bridge ID, right? So that bridge ID consists of two things, right? If you break down a bridge ID, you will have two things on it. You would have the priority and the MAC address. Now, what is 8 bytes? Don't forget that one byte is 8 bits. So 8 bytes will be 64 bits, right? Right? So the bridge identifier has 64 bits. Do we agree? Since it is 8 bytes. Do we all agree? Okay. Yeah. So it is 64 bits, right? So among that 64 bits, those 64 bits are shared between priority and MAC address. We already know that MAC address is 48 bits. How many bits is a MAC address? Is 48 bits long. So it must mean that if MAC address is 48 bits long, priority is 16 bits. 48 plus 16, 64, right? So this priority is 16 bits. So 16 bits, if we do 1 in 16 places, that's 16 bits of 1. If we do zeros in 16 places, that's 16 bits of zeros. So all switches by default have a bridge priority of 32768. Why do they have it by default? Is because it has all been zero. The 16 bits have been zeroed, leaving the last bit to be 1. Right? So, excuse me. So we have 100000000 making up 16. If you count this is 16. So if you convert it to decimal, the answer is 32768. So by default, all switches have a priority of 32768. So Cisco configured it like that, right? So that the choice of what to be the root bridge is based on MAC address, right? Don't forget that bridge ID is bridge priority plus MAC address. So, and don't forget that the bridge ID is what the switch STP domain network will use to choose the root bridge. The root bridge is the switch that has the lowest bridge ID. So as we have switches connected to each other like this, when they are first connected, they will all send their own personal BPDU frame. They will send it to each other. So this switch will receive the BPDU frame of this switch, of all the switches. Each switch will receive the BPDU frames from all other switches. So they will compare. Oh, between me and this other switch, which one has the lowest bridge ID? Now, the bridge ID, don't forget, is the bridge priority plus the MAC address, right? So, since the standard has automatically ensured that all switches have the same priority, 32768, so that the tiebreaker will be the MAC address. So that's the way you do elimination in secondary school. If we cancel out, since bridge ID is equal to bridge priority plus MAC address, and bridge priority has been made to be equal, we can cancel out bridge priority and say that bridge ID is equal to MAC address. Right? Does that make sense? If it makes sense, you can give me a thumbs up. Yeah. So the device with the lowest MAC address will be what is selected as the root bridge. No matter whether it's a layer 3 switch or it's a layer 2 switch. Once that device has the lowest MAC address, it is selected as the root bridge. Does it make sense? Daniel, your hand is raised. So it can be configured, right? You can configure in a way, but before you manipulate stuff, at least you need to understand what you're trying to manipulate, right? So this is the basic understanding first, right? So let's go into this network and see how we can identify the MAC address of so let's quickly check the MAC address of all the switches, right? So let's start with this. Enable is show version. So let's see the MAC address of the switch itself. Let's see if we're going to see it. MAC address, base Ethernet MAC address 0. So we're going to need this value. I'm going to create a table on the chart. Let us open a quick Google document. So don't like this font. I like just or EB Garamond. So Red Pay switch 1 as the MAC address of this. Red Pay switch 2. Let's go and find its MAC address. CLI bam 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 enable show version as a MAC address of this. So Red Pay switch 3. Red Pay switch 3 as a MAC address of show version 00 copy and paste. Red Pay switch 4 as a MAC address of enable show version of this copy. So distribution switch 1 as a MAC address of enable show version of this. Then distro 2 as a MAC address of this. Then core 1 as a MAC address of this. Port 2 as a MAC address of this. So I'm going to do a quick stuff, right? So this is our STP switch network, right? So don't forget that the switch with the lowest MAC address will be the root bridge. This switch is what? So from this list, which one has the lowest MAC address? Which one has, let's check through the list. Which one has the lowest MAC address? I want to see our responses. Okay. Yeah. It's not corresponding. Read the MAC address. You are going to the MAC address. You are going to consider all the digits. You're not just what's coming first or not. So this for core 2. So what's the final answer? No, look at job. More responses. More responses, please. Are we sure it is 1? Mm. Why is it not core 1? Ewa Ewa John. So in hexadecimal, right? 0 0 1 2 3 4 5 6 7 8 9 A B C D E F. F is 15, E is 14, D is 13, C is 12, B is 11, and E is 10. Excuse me. Yeah, in hexadecimal, right? So hexadecimal is 0 to F, right? So this 1, this 2, 3, 4, 5, 6. If you count 0 to 15, you should have 16. 0, 1, 2, 3, 4, 5 is 16. So in hexadecimal, B is 11. So if you compare core 1 and red pay switch, on the first is 0, 0, 0, 0, 0, 1, 0, 1, 6, 4, 6, 4, 0, 7, B 3. 0, 7 is smaller than B 3. Right? There's a way to convert um, from from hexadecimal to decimal. I don't have to. All the BPDUs, they've seen every other switches MAC address and all that. They will now realize that, oh, red pay switch 1 has the lowest MAC address. So all the switches will assign this switch as their root bridge. So once they assign this switch as their root bridge, they will stop sending BPDU frame. Only this switch will be sending BPDU frames. They will just be forwarding it they themselves will not send their own BPDU frame. They'll be forwarding the BPDU frame of the root bridge. Does that make sense? Does that make sense? Is it clear? So I think I want us to stop here. It done the complex. Right? And for me, it's better that we understand it, that we take time to understand it, than we rush it and we don't understand it. So we'll stop here, but we'll do a quiz to reinforce what we have learned. What I wanted. So are we ready? 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 Make some noise. Make some noise. Yeah. So number one, What's the answer? What's the answer? C. Nice. But 2, what's the answer? What's the answer for number 2? Okay. D. Nice. What's the answer for number 3? Sharp. What's the answer for number 4? Answer for number 4. Sharp. Answer for number 5. This one is a bit tricky. What's the answer for number? Answer is C. Answer is actually C. It's in binary. I will explain this later on. But let's go. Yeah, number 6. What's the answer? This is a bit tricky, so calm down and answer. What's the answer for number 6? Number 6A. Are we sure? Number 6. Are we sure? It can't be, you can't say between B and C. You have to choose one. I already showed you how to convert. You just talk, go back. Answer is C. Yeah, but there's nothing to convert there. One is 0. He said that a call. Seven.
Sorry, excuse me. Can I speak?
No.
Okay, so does it have to be the lowest priority as well as
I said no. It was a joke. Please speak.
it's fine. So it has to be the lowest priority and the lowest MAC address, right?
So it's the lowest bridge ID. right? The answer is lowest bridge ID. Bridge ID is MAC address plus priority. So if you add both, the one if you Folakemi, it was a joke. It was a joke. Like if you add both of them, if you add both of them, right, the lowest. So if you go back to the question, you will see that the priority here is 40960. That's higher compared to the priority here, compared to 32768. So by elimination, you already know that this priority is the answer is between B and C, right? Just by looking through, because you can already see that switch B has a lower priority than switch D, right? So B and C, they have very low priorities compared to the other switches. Then if you now check the MAC addresses, you can see that switch C has the lowest MAC address, right? So adding both, this switch C has to have the lowest, right? So it tells you that switch C has the lowest priority and it ties with switch B, but it has the lowest MAC address. So that's why that's the answer. Does that make any sense? Okay. So priority can be configured, right? That's an advanced concept, but let's first understand the basic first. So next, what's the answer to this? Everybody should get this. Okay. A sharp. Number 8. This is a simple question. If you calm down. Okay. In answer this question, you have to be calm. If you rush, you are going to miss it. So what's the answer? Yeah, answer is B. 9. This is simple. You need to be calm. The answer is D, actually. The reason why people are choosing A is because they were not calm. The other switch must have a higher MAC address because we want our own switch to win. So our switch must have a lower MAC address, but the other switch must have a higher MAC address. Does it make sense? So answer is D.
No, it doesn't.
Let's read the question again. In a scenario where a switch has a bridge priority of 4096 and its MAC address is this, what is the tie-breaking condition that must be met for this switch to win against another switch with the same priority. So we already know that the other switch also has the priority of 4096. So the tiebreaker is the MAC address. And I've been given that the MAC address of the first switch is this. So must the will the MAC address of the other switch be higher or lower? Will it be higher or lower? It must be higher, because the lower the MAC address, the chances are that our switch will be the root bridge. Yes, a trick question. So we want to ensure that we have the lowest MAC address. So the answer is D. Number 10. What is the order of comparison used by switches when electing the root bridge in an STP domain? This is tricky. This is tricky, but I trust you guys. The brains are just they lost. So what's the answer? The answer is D. Bridge priority first. So we got all 100% accuracy. So do we do another quiz, or should we call it good night? I feel like the quiz enforces what we have learned. I feel like the quiz helps us like enforce what we have learned, and I think I like how we are using the quizzes actually. So we should call it good night. Hey, oh, I'm the best teacher. Oh, thank you very much. Thank you for the compliment. Oh, right. So I think we'll just end by 10 o'clock. We end by 10 so that we keep it at 10. Right. So I was today's class. I was today's class. Oh. So I think we might have a class during the week, so that we can finish this STP. I didn't want to overwhelm us with a lot of information. That's why I said we should just stop. But we are close. We are close. We are close to understanding it. That's how it is now. Aishat, that's how it is. Your brain will be taxed for a while, and then you get to understand it. Sorry. Sorry. Don't worry. You can call.